Secure Shell Protocol. PowerPoint by Devin North for Network Systems, instructed by James Struther. So to start it all, where it all began, this guy here, Tattoo Yolomin, I believe is how it's pronounced, designed the first version of SSH, which will be referred to as SH-1, in 1995 in response to a huge security breach that happened in his university's network. Basically, it happened because they were using a pretty unsecure protocol at the time called Telnet, which we will go over later how Telnet and SSH kind of go up against each other. It was previously the most popular protocol used for logging into devices, but SSH1 added in a lot of features, such as adding in authentication, and it really helped guarantee confidentiality. 2006, SSH2 was released, and it came with the ability to run any number of cell sessions over a single SSH connection, which could really help out and really kind of helped with the whole backloading system. And currently, most operating systems are packaged with SSH software and OpenSSH, which basically sets legacy protocols as Telnet and SSH instead. We'll go over that in a second as well. So right here on this slide, we have a simple little rundown of how SSH stacks up against Telnet. And basically, as you can see, the pluses being pros and the minuses being cons. Basically, SSH is better in almost every single way except for terms of backwards compatibility. Because one thing that is good about Telnet is that it's basically on every single device due to the fact that it is legacy and you can use it on any device. However, the problem is how insecure it is, and one of the main reasons is that everything is sent in clear text. Clear text is, well, as you can see right here, everything here is clear text. And that's bad because if someone is intercepting a connection, they can clearly see what's being said. There's also no type of authentication protocols. In other words, there's nothing really to secure who is who. SSH uses public key encryption, which helps decipher and decipher stuff. That way, anyone in the middle that's looking can't usually understand it. It also has more overhead bandwidth, and the only real problem is that it's not backwards compatible, and that's not only with older systems that don't know how to run it. That's also a problem because SSH2 is not backwards compatible with SSH1. But the bottom line is that it's overall more secure and a better protocol. So the next thing we're going to go over is public key encryption. Now, this is really one of the main things about SSH that make it really good. So, in order to keep every interaction secure and safe, we need what else but encryption. SSH helps keeps online interactions secure by using what is known as public key encryption. PKE, for short, works by creating two different keys to use for authentication. Let's say you wanted to log into your Microsoft account. The SSH server would create two keys for you, a private key and a public key. The public key is shared to the SSH server and is used to match up with a corresponding private key. The private key is with the user at all times and is often called the identity key because it authenticates who the user is. And there's not really a way to lose it or really steal it outside of physical kind of things. When you log on to the server, it sends out the public keys of both the users and puts the login credentials through an algorithm to encrypt it. When it encrypts it, it basically puts it through this kind of weird algorithm. So if you were to send something such as AAA, it would encrypt it and make it WH0, something that just makes absolutely no sense. And unless if you knew how to backwards de-encrypt it, you couldn't really use it. And that's really the thing that makes it most useful. The encrypted message floats in the SSH server until a private key that corresponds with the public key that you sent out with it requests it. Basically, then it matches them up, and then it is unencrypted and sent into the login servers. Basically, the credentials you set were encrypted, and the SSH server made sure that it made it to the right destination without anyone being able to see it. So, if you did everything correctly, you should be logged in now. assuming you have the same password and username. So this is just a quick little visual. If we start up here at Alice, she says only Bob will be able to read this. And this is, I don't know what she's sending, but basically, in this example, so we have Alice's private key, and then we have her public key as well as Bob's public key, because she did request for Bob specifically to see it. So what happens is that it encrypts it, ciphertext, and it goes over, and then basically when it sends to the SSH server, it then tries to match it up with whatever private key corresponds to the public key, in this case, Bob's. And then with that, it uses it to de-encrypt it and give it to Bob. Now, as you can see in the middle, here's Eve, maybe an X or something, is trying to de-encrypt it. However, because she doesn't have the private key, nor does she have any other way to really decipher it, it stayed as ciphertext, therefore she can't see it. And that's what makes SSH overall more secure with PKE. So yeah. Another great feature of SSH is the SSH tunneling, or it's also called port forwarding. It's basically when an SSH client listens for connections on a port, and when it gets one, it tunnels towards the SSH server. To put it simply, it allows devices to call and connect to each other, primarily used in connecting a machine towards a port. This is used mostly for local forwarding. If you want to connect to a port on a device that's on a separate network, you would have to use remote forwarding. As the name implies, it can be done outside of the destination network by allowing access. This is both good and bad. It can allow someone to get into the network from the outside, which, depending on the person, could be a problem. Let's say if a hacker wanted to get in to steal some information, they could possibly use remote tunneling to get in. The main thing, though, that SSH tunneling is great for is that it can use port forwarding to get past firewalls that would otherwise render a port inaccessible. For instance, looking here, we have two different examples. So as you can see up here in the left photo, we have where the blue server is trying to connect to the red server. And although one of the ports are open, the 22 port, it can go through fine. However, the 80 port, it keeps on getting stopped by the firewall. Now, this problem is relieved once we have an SSH tunnel, because it goes directly through that way it can get to it. It can bypass firewalls fairly easily. If we look over here towards the right, sometimes, for a lot of remote networks, they have what is called a tunnel server, which is basically used especially for SSH tunneling. So as you can see, it goes through the firewall to the public internet, and then it goes through another firewall to get to the tunnel server. And then it uses that tunnel server in order to access other networks to get through. Now, this is both, as I previously said, it can be a bad thing, however, most of it's secured. Secure file transfer. So, file transfer protocol, or FTP, is not a new concept at all. It's been around long before SSH1 was invented. It's actually been almost by 20 years since it was first developed in, I believe, the 1970s. As the name implied, FTP is a protocol that is used when someone wants to send a file over a network. For instance, let's say you wanted to share a Microsoft Word document to a classmate. You could send it directly to them through the FTP service, such as FileZilla is a very popular one. I've used it before. With SSH, though, FTP becomes a lot more of a safe protocol and is often called SFTP, which stands for SSH File Transfer Protocol. The main problem with File Transfer Protocol is that it is sent in completely raw data. In other words, once you send that document over, if someone is in between, they could possibly intercept it and take it. And that's one of the biggest problems with it. However, combining it with SSH, making it SFTP, that causes it to go and it encrypts it again, and it uses the key system again. It really makes it a lot better. It should be noted, though, that some browsers actually won't let you use SFTP due to just incompatibilities. So it is recommended to usually just have SSH installed on the overall network, which a lot of OSs already do. OpenSSH. As we previously talked, it's more like OpenSSH is like a suite of SSH and SSH-related protocols. When installed, it replaces older, more vulnerable protocols such as Telnet with SSH and FTP with SFTP. The great thing about it is that, like most things that are developed around Linux, it is free and it's been updated since its release in 1999. I believe recently in April, they reached a new version 8, I believe. On Linux, you can even directly download it and install it from the terminal by inputting the command sudo apt install openssh/client, which any Linux user already probably knows this. So, last thing to really cover is the SSH client and remote desktop. And it's probably the most useful feature. It's basically allows you to connect directly to another host machine and control it. This is a very popular thing used in usually tech support in order to help people with their problems remotely. And all you really need to run it is as an SSH client application, such as OpenSSH. You need to enter in the correct credentials for the device you want to remote into. And the thing is that if it was entered incorrectly, the SSH daemon will be alerted, which is the component that listens to ports for remoting on most Linux machines, I believe. Make sure both of them have SSH, as previously talked about. And if it was done correctly, you should be able to remote into it. It's an overall simplified version, but it works something like that. So, in conclusion, SSH is a very useful protocol that has overall made networks more secure. It's so popular that it's even pre-installed on most major OSs. SSH is great because it has these things: public key encryption, SSH tunneling, secured file transfer protocol, and it can be used to connect to remote devices. Overall, SSH is very important, and if it's not installed on your computer, you're probably less secure. So, there it is, basically. This right here is just some works cited. Overall, pretty simple. Thank you for your time.